All right, let's get started with Math 321. This is support for chapter 2. And maybe I'll label this 2A. That's what I got listed as on our little syllabus. The first thing we're going to talk about is the real number line. This is pretty important for the rest of the class. Sounds like everybody's pulling out their notebook. Oh, wait a second. Figured that part was done already. My bad. So the real number line is a line it's an arrowhead on both sides. The center is 0. And as we go to the right, numbers go up. And as we go to the left, numbers go down. This happens from any position on the number line. So the next whole number above 0 is 1. Then we got 2. Then we got 3, 4, things like that. We go the other direction, and we have negative numbers. So I think they asked you a couple names about what certain categories are. The whole numbers are your counting numbers. I use the hashtag as short for number. This is short for number. Saves a little time writing if you use that as number. So this is like, you don't count 0 things. You start at 1. So this is like 1, 2, 3, 4, 5, and it just keeps going. Going to 6, add a comma, and put 3 dots. The 3 dots are called the ellipses. It's the 3 dots. And it means keep following the pattern. Without end. Why is it's gonna go up? How do I get this? It's a little bright, isn't it? There we go. Ah, shit. That's kind of clear. I'm gonna go back down. So these are my whole numbers. The next category we have are integers. This has all your whole numbers. It has 0. 0 is an integer. And it has what I like to call your negative whole numbers. That's not really a thing. Some math teacher sees this, they're going to be like, dude, don't say that shit. But I mean, that's really really what it is. For all our whole numbers, we have the negative versions of those. We got a little bit of blur. Let's see if I can clean that blur up. There we go. Found it. Is it on the inside? Yep. Just gonna leave it alone. Leave it like that. And then we have our rational numbers. Rational has the word ratio in it. A ratio, as we'll talk about much later, not much later, shortly, are fractions. This includes decimals that can be written as fractions. And we'll show how to do that. These include decimals that end. For example, something like 0.125 is the same thing as 1/8. This includes repeating decimals. (0.1111) and the ones keep going. One way we write that is 0.1 with a bar over it, and that's actually 1/9. I think I need to slow down. I'm going a little faster, aren't I? Yeah, tell me if I'm going fast.
Slow down.
Slow down. There we go. Some of them, it's hard to do these ones that repeat. You kind of have to know what the fraction is and recognize what it is. But like there's like crazy ones, like you could have 0.272727. It just keeps going. I can write that as 0.27, and the 27 is what repeats, so we put the bar over it. And this actually ends up being 3/11. It's kind of hard to figure out starting at 0.27272727. So it's not necessarily easy, but it can be done. That bar is called the repetition bar. I want to say that there's other unending decimals that do it, a few decimals that don't end. But right now, I can't really think of any outside of the B category, the repeating decimals. The repeating decimals don't technically end, they just keep going. I can't think of any outside the repeating decimals category, but maybe I'll look it up and talk about it on Tuesday. So those are like kind of like the numbers between these. Some of them. Like 1/8 and 1/9. 1/8 might be there. 1/9 is a little bit closer to 0. And that might be right around where 3/11 is. Just for some examples. Everyone ready? Does anyone need this up longer? All right. So the next thing on this category, the last one number set we're going to look at is the irrational numbers. They don't fit any of the other ones. They can't be written as a ratio or fraction. Unfortunately, these do show up in our class. And but what we're basically going to do with them is figure out what they look like as a decimal and just like go, okay, that's what it is. And we'll end up rounding. These are almost always, I can't think of any that are not in the category of decimals that don't end and don't repeat. Are in this category. One you're probably familiar with, at least have heard, is the symbol pi. That's pi. And it is an unending decimal. It's to 4 decimal places, it's 3.1415. But it keeps going without stop. They have competitions on March 14th all over the country to recite as many decimal places as pi as you can. And I've seen people, like the judges have the sheet of like pi to like 3,000 decimal places just written out number by number. And they listen to the person recite, and I've seen people do up to like 500. That's some crazy shit, remembering a sequence of 500 numbers. I can't even imagine. More common ones that you'll see are your square roots that aren't perfect squares. So the square root of 2 is about 1.414. This wavy equation sign means approximately. Not equal to, but approximately. Square root of 3 is approximately 1.732. The homework on the quiz is going to ask you to do shit like this. Quiz questions. plot 1.5 on a number line. And they'll give you the number line. The number line will be sitting there. And it will have shit like this. And what they want you to do is just click the dot where it goes. And they might have little hashtags in between them to mark the halfway marks. So like 1.5, if it ends in 0.5, it's halfway. It's halfway between two numbers. The number there, so 1 is here, 2 is here. Halfway between them is 1.5. So we plotted 1.5. If they ask you to plot negative 1.5, it's always also halfway between two numbers, but it's between -1 and -2. So there's -1, there's -2. Halfway is right there. That's -1.5. Are we having fun yet? We got more fun activities next hour. This is let's get some math bit in. No one's at the blast radius. That's disappointing. I ain't ashamed of my body. And let's face it, it's one of the most natural things to do. Everyone
You
farts.
know what doorknob is?
Uh-huh.
Someone farts and you say doorknob, you gotta run towards the doorknob, otherwise you get stuck in the top.
How dare you to come stop it?
I just trying to get about that.
Fucking bring it. You better take me down though. I can't hit you back, but I can get security to come rough you up.
Is there security?
It should be.
If I call security, someone will show up. There's cops on campus. So this is -1.5 and that's positive 1.5. Both of these are 1.5 units away from 0. Units away, or maybe like their distance from 0. We actually have some math notation for distance from 0. It's called the absolute value. Absolute value, and it has bars that go with it. It's the giant vertical bars that go around a number. Absolute value actually yields the distance from 0. So both the absolute value of 1.5 and the absolute value of -1.5 equals 1.5. This is from 0 is what it is. The way you're going to use it is if it's negative, just make it positive. That's all it means. after doing the math inside, I should say. Like if there's some math operations, you gotta do the math operations first. We'll be covering that at some point in this 321 hour. Then make it positive. The fuck? You guys ready for more? See a couple pins still going. I'll pause for a little bit longer. Next, we're talking about fractions, and we're going to break it down in terms of something I like, but pizza. I'm a big fan of pizza. I like stuffed crust pizza. I like the curry company right down the street.
Yeah.
You get one of their the Indian pizzas with chicken on it. Oh my God, there's so much chicken on the pizza. It's insane. You get like a large
Curry chicken or something.
curry chicken or something like that. A large curry chicken pizza, it's not like probably 2 or 3 pounds of fucking chicken on it. It's insane.
Throw me some extra credits later on when you get my friend works there. I can make people. Get your family size. You ever seen that?
Yeah, I can't fit that in the fridge. I've tried. Oh shit, you know someone that works there. Hmm. Look at you just pimping out your friend.
I could, there's something else I could already, and I don't take.
Yeah, that's true. He scratches your back, you scratch his back.
Yeah.
All right, are you guys ready? Okay. So now we're gonna talk about fractions. And now that we've mentioned it, let's just go with that curry chicken pizza. I ain't gonna try to draw the curry chicken on there. It's got fucking cilantro and all sorts of shit on it. It's pretty damn good. Now let's say it comes with 12 pieces. Break it out like a clock. Like one of those back there. I know a lot of you don't have them at home. That's a clock. A non-digital clock. All right, so let's say me, what am I going to do? David is going to have, I don't know, if it's let's go, if it's a large pizza, I'll probably eat 3 slices. My wife, Angie, will probably only eat 2. Cody, let's go with Cody. Cody might equal 3 with his 3 slices right there. And I've got A, I've got C, I've got D. Let's go with the B. Let's go with Brianna. Brianna, she's a hungry girl. She eats 4. No judgment. She probably fucking runs a lot, burns a lot of energy. I don't know. So the way we write fractions, fractions show relationships the relationship between a partial amount and the whole. And we make the fraction, the partial number goes on top and the total goes on bottom. Now I'm sure, I'm pretty sure there's a question about what these sides are called. The top part is called the numerator. And the bottom part is called the denominator, yeah. I can't tell you how many times I wrote deminator rather than denominator by switching the N and the M by going too fast. I have no idea why. It's like I'm gaming or some shit. That's what they're called. That's a long way of saying top and bottom. Math people and their fucking words. Just want to slap them sometimes. Okay, so let's look at what we got here. David. Oop, I just hit some shit. Oh, brightness. Fuck. Brightness makes it hard to see. There we go. Lift that shit up. Blind the teacher, but make it easier to read. How about that? Oh, that'll kind of work. David has 3 slices out of 12 slices. 3 out of 12. That's a common way of talking about fractions. We'll say 3 out of 12. My 3 slices are right here. D, D, D. Okay. Angie has 2 slices out of 12. Cody has 3 slices out of 12. And Brianna has 4 out of 12. We're getting there, yeah. First, I want to mention adding real quick. Let's add up our slices. I've got 3 12ths plus 2 12ths plus Cody's 3 12ths plus Brianna's 4 12ths. We ate the whole fucking pizza, right? So instead of if we didn't look at us as individuals, but we looked at a we, this should equal we ate 12 slices out of 12, right? Well, it turns out that if we add those numbers on top together, we just so happen to get 12. And if I didn't want to talk about 12 slices out of 12 slices, that makes me sound like a moron. That's just one pizza, right? If the number on top and the number on the bottom are the same, this equals 1. We'll talk about canceling or simplifying a little bit. Let's take a look at David's and Cody's slices in particular. Everyone ready? Okay. So this comes under the idea of equivalent fractions. I'm redrawing the part of the pizza that just has me and Cody. I could also draw this pizza if I didn't cut it into 12 slices. If I only cut it into 4 slices, David's eating this quadrant or quarter, Cody's eating that quarter. Well, over here, these were 3 out of 12 for both of us. If we look at this, the total number of pieces here is 4, and we've each had 1. These are called equivalent fractions. They are equal. We're talking about the same quantity of pizza. I really shouldn't talk about fucking pizza at 5:40 at night or 4:40 at night. This was not well fucking thought out. Right? This wasn't well thought out. Like, I'm not having dinner until fucking 7. This wasn't well thought out. So how can we go from 3/12 to 1/4?
The same denominator.
We want to try, we can show that they're equal. We're going to make them have the same denominator, same bottom. This is called simplifying or reducing. Is writing this larger fraction as the smaller one. So if the homework asks you to simplify or reduce the fraction, they're asking you to do what we're about to do. How we go about doing this is we write the top and bottom. In terms of their factors. And factors are the numbers that multiply together to make the big number. Make the value. So I'm going to start with 3/12. And 12, I can write as 3 times 4. I could also write this as 3 times 2 times 2. The dot means multiply. And it's not like where the decimal goes, it's a little higher up. Now, I know like in elementary school, they use an X, they'll say like 2x3. But as soon as you start learning algebra, like in high school or junior high, if you're one of the clever ones, X becomes a variable, and then like using it for both is fucking confusing. So we just switch to a dot. So what we're gonna do is we cross off things that are on the top and the bottom in pairs. Cross off things in pairs. Cross off pairs between top and bottom. And replace with a 1. So here I've got a 3 on top and a 3 on bottom. I can cross them off and I'm going to replace them with 1s. Or I could do that down here. So this says I have 1 on top and I've got 1 times 4 on bottom. And 1 times 4 is 4. And so we got our 1/4. That's what we were looking for, right? Same thing here. 1/2 times 2 times 1 is 1/4. This process of writing the top and bottom numbers in terms of their factors, this is called factoring. That's the magic name for it. When I write 12 as 3 times 4, I'm factoring 12. Now, the lowest you get, does anyone need a 700? If you do, raise your hand. If you don't, I'm going, okay, you do, that's fine. She's not even looking up here, so I don't think she was raising her hand. I'm going on. So when I did it like this, when I said 3/12 was 3/3 times 2 times 2. These numbers down here are called prime numbers. Prime numbers, what makes a number prime is they can only be written with factors of 1 and themselves. I can't break down 2 into multiplying 2 whole numbers without using a 1. I just can't do it. Numbers in this category, 2, 3, 5, 7, 8, 9, 10 are all multiples. We've got 11, 13, 17, 19, 23, 29, 31, and the list keeps going. You will never use, oh, I can't say never, but it's unlikely you'll ever use prime numbers higher than this in this class. Unless the computer just decides to be a dick. Let's face it, computers do like to be dicks. Does anyone not know the difference between an even and an odd number? An even number is divisible, you can divide it by 2. An odd number you can't. What? I didn't hear it.
So actually, this.
Okay. Even numbers can only be divided by 2. Not only, but can be divided by 2. Odds cannot. And when I say that, I mean with a whole number left over. There's nothing wrong with not knowing what an even and odd number is. I don't know why you're trying to shame her. It's pretty fucked up.
I do,
He's just being a dick, right? Trying to shame you for shit you even knew.
Yeah.
But even if you didn't, that's a dick move.
He's just trying to.
She does the same shit as why did you?
Ashton, if you ever feel like slapping the shit out of him, I will pretend I didn't see.
Oh,
If you go
okay,
outside.
then that's the thing though.
I might have to trim that out of the fucking video.
Oh.
That's me condoning violence, right? I'm not supposed to do that in my class. What's your name?
Manny?
Maddie?
No, Manny.
Manny and Ash. Okay. You two are pretty vocal.
What?
What's your name again? Daniel. Melinda. You four are the only ones I've really heard today. Daniel, Melinda, Manny, and Ashton. All right. So the neat thing about this is the only even prime number. All the rest are odd. Now we're going to do this factoring thing a lot. So like, what's an easy way to do it if you don't just recognize this shit? So how do we find factors? What we're really doing is we are finding finding numbers that we can divide by. I can do 12 divided by 3 equals 4. Which means these two are factors of 12. And when I say we can divide by them, what I mean by is evenly divisible. Evenly divisible means no decimal left over. Remainder is the word that we like to use in math. If you do it in a calculator, there's no decimal remainder. Another way of writing 12 divided by 3 is using fractions. This is the same thing as writing 12 over 3. So fractions, the fraction bar represents division. This is easy for you, isn't it, Daniel?
Nah.
Nah, you're busting out all the fucking words. Busting out numerator and denominator, that's some shit right there. That's not a word most people memorize. All right, so well, like, what's some easy ways to do it? I'm gonna give you a couple like neat things, neat ways of looking at it that'll help you get through the first few prime numbers. Well, at least first few numbers, maybe not prime. So if a number is divisible by two, it ends in 0, 2, 4, 6, or 8. The last digit is one of those. These are all our even, this will be our even. Anything that is divided by, you can divide by 2 is an even number. 3 is trippy as fuck. I can't explain why it works, and putting it in words is a little hard, but I'm going to try. So if it's divisible by 3, this is how you can find out if a number is divisible by 3. First, add up the digits. Then see if that sum is divisible by 3. I'm going to show you an example. The number 111. If I add up the digits, I have 1 plus 1 plus 1 equals 3. 3 is evenly divisible by 3. Which means 111 is also. 111 divided by 3 is 37. Now, if I just looked at the number 111, I don't recognize that's divisible by 3, but adding up the digits shows me that it is. Does that make sense? Why does it work? Don't fucking ask me why it works. I can't tell you. It's magic. It's math magic. Math magic, not mathematics, but mathematics. The other big ones that you'll notice are 5 and 10. 5, they end in a 5 or 0. And 10 ends in a 0. That's my 0. It looks like an O. And we'll do some more with that on another day. Like Tuesday. You have to stop recording.